Okay, so here we have some graph paper that is laid out in a way that it's convenient for graphing trig functions. The x-axis is labeled with some angles in radian measure, and the y-axis is labeled in units of height. So we have here pi over 2 radians. If you count the number of squares, that is 6 squares to the right to make pi over 2. Now that tells us that each square is 1/6 of the distance to pi over 2. So 1/6 of pi over 2 is pi over 12. So each square along our x-axis has a width of pi over 12 radians. So let's graph a function here. Let's take y equals let's go up here. So y equals 2 times the sine of x minus pi over 6. Okay, so to start with, let's identify some things about this function. Well, the 2 in front of the sine function is called a vertical stretch in algebra. If we multiply a function by a number bigger than 1, that's called a vertical stretch. And here in trig, that has a special name just for trig functions, sine and cosine specifically. That's called the amplitude. So the amplitude for this function is 2. And that word amplitude tells us that from the center line of the graph, and I'm talking about a horizontal line that would go through the center of the graph, the amplitude tells us how far up and how far down the graph extends to get to its highest point and its lowest point. So that's what the word amplitude means here. The other thing that we need to think about is the period of this particular function, and period is always, for sine and cosine, the period is 2 pi divided by the value of b. Well, b in this case is 1. The b is the number that would be between the sine function notation there and the parentheses. So 2 pi over b, so 2 pi over 1 is just 2 pi. And the word period indicates how wide the graph will be to be able to draw one complete cycle of what this graph is doing. So from left to right, we need to go a horizontal distance of 2 pi in order to have one complete picture of the shape of this curve. The pi over 6, the letter that usually represents that spot is h, and h comma k for this particular problem is the point pi over 6, 0. Pi over 6 is any horizontal shift or translation, and the k is any vertical shift or translation. So there is no vertical shift on this one. So we're starting off, the origin has essentially moved to the point pi over 6, 0. Now, the next part that we figure out are the special points along the curve where the curve hits its center line or the highest point or the lowest point on the curve. Now, the sine function generally follows the pattern of center high, center low, center. So center high, center low, center is the shape of a basic sine graph. So in order to find those places where the graph is on the center line, the highest point, center line, lowest point, center line, we essentially are going to be solving 5 little linear equations. Those 5 linear equations come from b times x minus h equal to the quadrantal angles. Now, if you're not familiar with that word quadrantal, these are the angles that separate the quadrants. If you think about your first, second, third, and fourth quadrant, the terminal side of each of these angles would be the line in between the quadrants. So we have 0, pi over 2, pi, 3 pi over 2, and 2 pi. Those are our basic quadrantal angles. So in this particular problem, we have 1 times x minus pi over 6 equal to each of these numbers. So in order to solve for x on each one of these, all we need to do is add pi over 6. So in each case, each of these 5 little linear equations that we would have, in order to solve for x, we would have x minus pi over 6 equals 0. We would have x minus pi over 6 equals pi over 2, and so on, all the way up to x minus pi over 6 equals 2 pi. So in order to solve for x, we would add pi over 6 to both sides. So that would give us values of x of 0 plus pi over 6 is pi over 6. Pi over 2 plus pi over 6. We would have to get a common denominator, which would be 12, so that would make 8 pi over 12. Pi plus pi over 6. Let's go ahead and do 12ths there as well, so that would be 14 pi over 12. And then 20 pi over 12 if we keep 12s. Remember that our graph paper is divided up into each little square is a width of pi over 12, and that's why I'm not reducing these fractions. I'm just leaving them in terms of 12ths. And the last one would be 26 pi over 12. That's 2 pi plus pi over 6. So might as well go back and change pi over 6 into 2 pi over 12 just to be consistent here. So these are the special points where the graph crosses center line, high line, center line, low line, center line. So let's go to the graph paper. So I'll just scroll up and start drawing this graph. Okay, so we have the shifted, the shift, the horizontal and vertical shift was pi over 6, 0. So that puts us right there. And then that corresponds to this 2 pi over 12 as well. So 2 pi over 12. 8 pi over 12 would be 8 squares over, or 6 more squares from the starting point. So there's 8 pi over 12. 14 pi over 12 would be located right here. 20 pi over 12, and I'm just going 6 additional squares each time. So here's 26 pi over 12. And the amplitude here was 2. So the amplitude from this center line, the amplitude, we go up a distance of 2 to get to the highest point on the curve, and down a distance of 2 will put us at -2 on the y-axis, and that will be our lowest points that the curve touches. So then we draw our shape, or we could go ahead and put some points in here. So the sine curve starts on the center, so this is our center, and then goes to high and center. Low would put us here, and back to center. So now we draw as a nice smooth curve that goes through these 5 points. So this graph would look something like this. This would be a fairly accurate graph, a good rough sketch, let's say, of our function, which was y equals 2 sine x minus pi over 6.